Bismillah ar-Rahman ar-Rahim. This is a October 2025 41 variant and complete mechanics paper. We are starting now. Question number one. Question number one, we have mass is a 900 kilogram with straight horizontal road and friction force 350 and instant the car is moving, speed 15, acceleration this month. So find driving force. So naturally, you know it very well. Applied force and friction force. So what is the formula? Net force is equals to MA. I can say capital F minus small f is equals to MA. Applied force, I don't know. Friction force is 350 and mass is 900. Acceleration is 0.25 and 350 will add. So 900 times to 0.25 plus 350. And I'm finding applied force. So 575. So 575 newtons. So we have done the first part. So Alhamdulillahi Rabbil Alameen. Second part is a power. What is a power formula? Basically, power formula is work done over time. But you know, if we convert work done force into distance over time, and distance over time is what? V. So we know power F into V. So I'm using this formula. If I make it power, so power is F into V. And power is equals to F is at 575 and 15. So I get 8625. 8625 watt. So we have to convert in kilowatt, must. So power is divided by 1000, so 8.625 kilowatt. So I hope so the concept of the question is completely over. Question number two particles P and Q. Okay, mention here 3 and 5 kilograms, and her smooth plane. And he mentioned clearly P is thrown with speed of 4 towards Q. Q is rest. P speed is 1. Find two possible speeds of Q after collision. So let's start. So we have two situations. So first of all, I'm going to show you this is a 3 kilogram, 5 kilogram P particle, Q particle. This moving is speed of 4 and the other speed is 0 and is a before collision and now after collision. After collision, what story we have? So after collision, which story is? So this speed is 1. Now we have two possibilities. One possibility is the same and one possibility I'm going to show you because he said two possibilities. You know it very well, students. When lighter particle hit with a heavy particle, sometime it comes back. So it means this one will come back. So we have second possibility if this come back, not right side backwards. And you know we have a condition whenever this observer's eye, and you know we have a two possibilities, and it is a basic criteria I'm going to discuss. Whenever the particle is going away from observer, look on top. If the particle is observers, the part going away, velocity positive, is coming back, velocity negative. So this is a positive both, but here it is going backwards negative. So formula is what? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Law of conservation of momentum. So M1 V1 means 3 4s are 12. And this is 0. And this is what 3 1s are 3. And this is speed is, I don't know. This is speed is X. I call as a X1 or I can call as a V1 and V2. V1 and V2. So what is this one? So we can say 5 times 2 V1. So this subtracted 905. 905 is coming 1.8. So yes, 2 9, so 1.8 meter per second. So one possibility is this. Second possibility is what? So same formula I'm going to use. Check it, students. Everything same. Only small change. So copy and paste. The only thing, one change only. And what is that? Speed is a -3, negative. So here I'm right because y negative going back to observer. So -1. So I get a -1 into 3 give us -3. 3 goes there, 15. 15 by 5 got a 3 meter per second. So we got a two possibilities. Alhamdulillah Rabbil Alameen. So V2 is this one. So the same question, we have a second part. What a question said. So lambda is a kinetic energy. Lambda is more than zero. It means maybe the two answers will come lambda, one positive and one negative. And lambda representing the kinetic energy. Okay, and during the loss of so actually this is called loss. So we are going to calculate loss in kinetic energy in both options using V2 and V1. So let's see what happens and find out the but we find out dot that is a which one, a positive. So what is the loss in kinetic energy? So before collision is what? Let me write before collision. What is kinetic energy before collision? Half mv square. Because no motion, so only due to the particle p, and half mv square, and I got a 16, so 16, I've got a 8 3 24 joules. So before collision, and after collision, kinetic energy after collision. So let me find out this one after collision. So let me calculate, sorry. Half into mass, m is 3 and speed is 1. 3 into 1 square plus half into 5 into 1.8 square. So I'm calculating this one and let's see what answer. Well, half into 3 plus half into 5 times to 1.8 square, and I'm getting here 9.6 joules. And if it loss, I will calculate a loss. So loss turn 24 minus 9.6. So 24 minus 9.6, and I got a 14.4. Loss is this one. So loss is 14.4 joules. Now I'm going to find it. This is condition number one. Now condition number two, before remains same, before will not change. I write a before, I just do one thing. Though there is no need to show this full, just I'm okay, better to I'm copying full and do a small change. There is no need, but just sake of your understanding only. Before no change, after change. What is after? Because velocity is after is 3. So I'll use here not 1.3, I'll use 3 here. But problem is coming when I use 3, okay? So what is coming from here? It is giving us, let me check once again, half into 3 plus half into 5 into 9 is giving us 24 joules. And you see 24 joules, 0.24 joules becomes 0. So loss is becoming here 0. So that is why our answer is a top here. This is my answer. Just sake of understanding, just I explain. Otherwise, no need to do this one. Okay, anyway. So question number 2 is completely over. Question number 3 we have, and he's saying that we have given 4 forces. You can see clearly 4 forces are given. Okay, and we need to find either order, the magnitude and direction of the resultant force. Okay, so let's try to do it. So first of all, I will resolve forces. Is very clear. So this has two component, one parallel to x-axis with 35-degree angle and one parallel to y-axis. So with x-axis always cos. So 28 is a force, cos 35. And this is what 28 force, sine 35. So what I can do here, students, this parallel to x-axis is a parallel to y-axis. Angle 50 here. So I can say it's 72 cos 50, very clear. And this is 72 sine 50. Now here interesting part. What is interesting part is given 70 in this way. So what I can do, I will break here. Look at here, I break it here. So 50 from here and 50 plus 490. So this is a 40, confirm 40. So because 50 plus 490 comes. Out of 70, 40 gone 30. So this is a 30 gap, 30. So if I use 30, no problem at all. Or if I use the other one, what the other one 60. This is a 60 degree. I think I can use 30 and 60 both, no problem at all. But I am using 60. So this is 60 here. So I'm writing here 35 cos 60. And downwards, very clear, 35 sine 60. Out of 50, 40, 90, correct. So out of 70, 40, 30, correct. Okay. Now, students, I'm going to find Rx and Ry. So let's see how we can get Rx now. So this right side force is, I'm not sure about it. So normally I take this positive and this negative. So I'm writing now 28 cos 35 plus 72 cos 50 and minus 35 cos 60. So, which I'm going to calculate now. And okay. So I'm writing 28 times 2. Let me check. Calculator must be in degree mode. Make sure degree mode. Okay. So 28 times 2 cos 35 plus 72 times 2 cos 50 and minus 35 times 2 cos 60. And I'm getting this value, and I think so I should type in 4 dp minimum 51.716965. Okay, so this I got it. Okay, and now I'm going for the Ry component. Ry, interesting. We have two possibilities. Anyway, so I will take the top one as this one, these two forces, and these two forces downwards. So I'm writing Ry. So first of all, I'm adding 45 positive upwards, 28 sine 35 positive. Again, these two forces negative because acting downwards. 35 sine 60 and negative 72 sine 50. So I'm going to type in calculator 45 plus 28 time to sine 35. Minus 35 time to sine 60. Okay. And minus 72 times 2 sine 50. And if I check in calculator, Ry I'm getting is here negative 24.4. Look, I got negative. It means understood that. So bigger force is downwards, smaller force upwards, smaller force upwards, and bigger force is downward. That is why I'm getting the difference is negative. Clear dip. Okay. So this is the Rx clear. So if I make a one triangle, you can understand same time. So look, so Rx is positive, no issue at all here. But Ry is positive, negative, I'm drawing it here. So Rx is 51.7166 and Ry is negative. I'm not writing negative 24.4059. 4059. Okay. So if I make a triangle, I'll make this triangle. This is called angle direction. I call as alpha. Okay. Now I'm looking for what? I'm looking for resultant force, which is here. I'll use Pythagoras theorem, r square equal rx square plus ry square. So I'll take a root and root of the whole. So this square and this square. Negative sign you take or you don't take, no problem at all. Okay, negative sign you take or you don't take because ultimately it's come positive. Also, answer of the this resultant force is coming with me is 57.2 newtons. Okay, this part is very clear. Now, how to get the angle? So I can find alpha is equal to tan inverse opposite by adjacent. 24.4059. No need take angle negative. So this is negative sign, sorry, 696. So when I take tan inverse, bracket 24.4059, 59 and divided by 51.71696. The answer is turned to be 22. This alpha is coming 22.9. Now is okay, 1 minute. Let me check once again. Uh, tan inverse. Okay. And Ry is 24.4059. and divided by 51.71696. So this is coming with me 22.9 degree. Okay, 22.9 degree. Okay, but thing is that it said this one. So how to answer? How to answer for it? So I can say here below the axis, or I have the weight right. This is 60 minus this. So I can say that direction is, you have many ways to write it. Direction, okay. So what is direction? 360 minus 22.9. So when I say 360 minus, so I get answer 337.1 degree with x-axis, with positive x-axis. Okay, sometimes we have to answer for the bearing as well, or sometimes we can say below the x-axis. So if you write 22.9 below x-axis is also correct. So this is another way of answer. So I hope so the idea is very clear. Yes, students, this is a typing error. This is a not 22, this is a something else. I checked it now. Is a 25.3 degree. So this is a 25.3 degree. So when I subtract from 360, so we are getting 334.7 degree with the x-axis. Or we can say 25.3 degree below x-axis. Okay, so both answers are correct. Third option, we use bearing. What is the bearing idea, if student, if you want to know? So from north, this is a north, from here till here, this is called bearing. So 90 plus this angle. So if I want to go for bearing, so 90 plus 25.3. So if I check it, so it is turned to be 90 plus 25.3. I'm getting 115.3. So three options we have. I hope so the concept of question is completely clear. Question number 4, we have two particle A, B mass is a m kilogram and 3 kilogram. Okay, mentioned clearly. Okay, and angle is given this. I can do one thing. Angle is equals to sine inverse 0.6. If I bring sine on other side, so sine alpha is 0.6. Okay, so I call this angle as alpha. He is saying further that 0.75 is the height of the particle A, and release from rest. Naturally, they start from here 0 speed, and when it reaches down here, speed is 2, clearly mentioned here, and friction is 10 over 3. And I think this data is clear. But he said energy method. Here, if you use the Newton law method, you will lose here some marks. So that is why I'm not going for that. Make two equations and solve them simultaneously by Newton's law. I'm going for the energy method. So basically, basic formula use what? Work done by applied force, work done by frictional force, kinetic energy plus potential energy at endpoint minus kinetic energy plus potential energy at starting point. Okay, throughout the particle is coming, it's moving itself. Capital F is 0. If this is 0, so work done by applied force is 0. So that is why I'm writing here 0. Okay, so 0. And now, first of all, let me expand the bracket. Expand brackets. So kinetic energy E for end, potential energy E for end, and K S for start, and P S for start. Okay. So, we're starting naturally, current energy at the end is bigger. So, KE at the end minus KE at the start. This is actually gain in current. It's called gain in current energy. And when I'm writing potential energy at, so here I'm going to make it here, for example, potential energy at end minus potential energy at start. Or I can say that this I can say in simple language, gain in kinetic energy plus loss in potential energy. Okay, this is zero, and this is what? Friction force. What is about the friction force? You student, you know it very well. When this particle will fall down 0.75 meters, it will go 0.75 meters. So what is the formula for this? You know it very well. Small work done by friction force is friction force into distance. And friction force is 10 over 3 and distance is same 0.75. So here I'm writing a simple 10 friction force into distance. Friction force 10 over 3, distance is a 0.75. So left hand side I got a negative 2.5. Now student, let's proceed for the gain and kinetic energy. How to get this one? So as it's speeding up, so it has a gain. Okay, so let's find half mv square. I'm writing now here half m2 square. Why 2 square? Because we just hitting the ground. Okay, what about the other? Here it has speed also same mgh. Mass is a 3, g is 10, h is 2. Half m, sorry, half mv square. Half mv square. So this is a gain and energy. If I calculate it, if I calculate students, so what is turned to be? This is a negative 2.5, and here I get a 2m, and here I got a 6. Okay, this is done. What about the other one? Loss in potential energy. So naturally, particle is falling down. So loss in this one is very clear is mgh. And what is mass as m? G is 10, H is 0.75. And I'm writing here in negative sign. So I'm writing here this value in negative sign. You may ask why negative sign, sir? Reason? Because it is because losing. And what about the other one? So here it is gaining. How much it falling down? 0.75. And this how much it will move up? 0.75. So basically I get a triangle here. Okay, and this is what distance? 0.75. And this height I want to know it. And what is the basic technique? If I want to apply triangle technique here and 0.75 and this alpha. So opposite by hypotenuse, I'm finding opposite by hypo is equal to sine alpha. And sine alpha value we have zero point 0.6. So this multiplying there. So height is becoming 0.75 into, sorry, yeah, 0.75 into zero point 0.6. And I'm getting 0.45. So height is becoming here 0.45. So this is a 0.45. So MGH, I'm writing here MGH. M is 3, G is 10, height is a 0.45. So when I calculate this one, I'm getting here negative 7.5 M. And here I'm getting here 30 times 2.45. And I'm getting here 13.5 positive. So I think it's clear now. Now I can finish my question. So these two values, I've solved it. I got us 5.5 in negative. Okay, and plus 19.5 and negative 2.5. So I bring 5.5 on left hand side and 19.5 and plus 2.5. So let me calculate 19.5 plus 2.5 and divided by 5.5. And I got a 4 kilogram. So I hope so. The idea is very clear. And the concept of this question, if I use Newton's law technique, students, so you will, according to the teacher's report and mark scheme, you will lose here straightforward 2 marks. I hope so. The concept is. So question number 5, we have, let's read a question carefully. He is saying that particle of mass 5 kilogram in equilibrium. When I say equilibrium, mean acceleration is naturally is equals to 0. So it's acceleration 0. Okay. And maintain the force acting is 8 mg acting from top. And coefficient friction is given 0.5, all right, and the point P is on the point of slipping down. So about the point about to move down, you can say the word about to move down. So naturally friction will be backwards. Okay, so first of all I talk about the weight component. What is the weight component, students? So weight is this, mass is m kilogram into 10. Into 10, I got a 10 m. I got a 10 m. So what is this? So this is 10 m sine theta. Okay. And further, so what is this component acting this perpendicularly this way? So this is R, normal reaction of the particle, and 10 m cos theta. 10 m cos theta. Okay, done. So this is okay. This I resolve the weight components of the particle. Now let's talk about the weight, the force. So when you talk about a force component, so force has a two component acting, one acting because like when you are pulling downwards, so one act particle will pull parallel to the downward surface downwards and one inwards. Okay. So interesting part, when two forces are parallel, a line cut, if this theta, this also theta. So in this sense, this theta. If this theta, you can see this theta I mentioned here and this theta I mentioned here. So common sense, this will be what? 8m. I'm writing here 8 mg cos theta. Why cos theta here? Because reason is very clear, when angle given cos theta, when angle not given sine. So here I'm writing 8 mg cos sine theta, sorry, sine theta. So I have all components. Okay, this I'm writing also same way. So here I'm writing this is 10 m because mass is m. So 10 m cos theta. So I think all points are clear now. So because about to move downwards, where's the friction, students? Friction will be backwards. Okay, all forces are resolved. Now, first of all, I will talk about the friction. This is acting upward, these two forces acting downward, inside, outwards, inwards. Okay, so they are equals to each other. So I can say, students, very clearly, R is equals to 8 mg sine theta plus 10 m cos theta. Okay, second part is here. This is I got it, R value. Now I'm going to discuss about the upward forces equal downward forces. So I can say here F is equals to what? 8 mg cos theta plus 10 m sine theta. Okay, let me check. mg. Here m only, yeah, as m into 10. Correct. Okay, 10 mg. Okay, is all clear. Okay, so I have done up till here. Now I will connect them. How to connect them? Because basically mu is given by him. So what is the formula we have? F is equals to mu R. So F value full will go here. R value completely will go here. And mu value will go here. I think point is very clear. So I'm going to plug in 8 mg cos theta plus 10 m sine theta equal to zero point 0.5. I am writing half. In the bracket, I'm writing 8. Okay, I better do, I'm copying the R value completely. So this value copy and I'm pasting here. Okay. Now students, this 2 multiply on the right side or cancel from inside. So 8 mg cos theta plus 10 m sine theta and 2 cancel 8 and 10. I got a 4 mg sine theta and 5 m cos theta. So I think you can see, students, m is available in whole equation. Divide by m, I got 8g cos theta. I got 10 sine theta. 4g sine theta and 5 cos theta. Okay, now I think I can do it easily. So first of all, I have to collect all sine values together, and it's because ultimate task is to get the theta value. So I think so for 40 is a 10. So this is a bigger, I bring this sine here and this on the other end. So I can say 4g sine theta negative 10 sine theta and 8g cos theta and negative 5 cos theta. So what is common from here, students? Sine theta common. So 4g 4g minus 10 sine theta, and here 8g minus 5 cos theta. So I can bring cos under it and this on this side. So I get a 8g minus 5 over 4g minus 10 equal to tan theta. So if I take a tan inverse of this side, so I'm going to type in calculator. First of all, 8 times 2 gravity value 10, and 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 minus 5. Okay, 840 minus 5, 75 comes in the numerator. 75. So 75 comes, so 10 inverse. So 8, 10, 80 minus 75, and 10, 40 minus the 30 comes here. So when I take a time, so 75 divided by 30, so 75 divided by 30, and take tan inverse of this. So let me check in again, once again. So yes, after typing in, I get a 68.198. After rounding, I got 68.2 degree angle. I hope so. The concept of the question is completely clear, and the completely question is question number 6. We have, students, the particle A of mass 2.5 is released from rest from top of the smooth plane. Smooth plane means friction throughout is 0, and makes an angle sine this one. So you know, if I take it this alpha equal to sine inverse 0.2. If I bring sine on other side, it becomes sine alpha is equal to 0.2. Okay, further saying particle A collides 2 seconds later with the particle B. So it means A is coming downwards, okay, and B is moving up. So A is coming downwards, B is moving upwards. And B before collision is 3.5, mass is 3 kilogram, and after collision speed become 0.5 down. This means after collision it goes down. So situation is what we have. If I make it, this is a particle A, let's say, and what is this? Mg sine theta or alpha, because this angle I have taken alpha. Friction backwards, and what we use normally formula, net force is equals to ma, because particles moving downwards. So this is a weight component minus friction equal to ma. Why I'm doing so? Because I'm looking for acceleration logic. You have, we have, and time is 2 seconds. So time we have, and we need to find out the velocity, and I'm looking for acceleration first. Now, what is the mass? 2.5. Basically, this 2.5, gravity 10, sine alpha is, I just got it, 0.2, friction 0, mass again 2.5, 2.5, 2.5 cancel. This I got a 2, so acceleration becomes 2 meter per second. And data is enough for us, so I'm going to get the answer. So what is the formula now I'm going to use from here? V is equal to U plus AT. V is my job, U 0, acceleration 2, and time is also 2. So I got a 4 meter per second. Now I'm going to plan now, students, what situation we have. Or I make it, this is before collision, and this is after collision. 1 minute. This is before and this after. Okay, or I can write it here before, here after. So before what situation? Particle, this is a particle A. Its mass is 2.5, and I will make it, or just a minute, please. Copy, paste, and both particle paste here. Okay, before, what's the situation? This A and this B, this A and B. Before, A is traveling downwards and B is traveling upwards. But after hitting A, B will move downwards and A will go upwards. And you know, students, we have discussed in previous lectures whenever observer's eye is here given. So when a particle is traveling, look, I mentioned here, when particle, this observer, if particle goes away from observer velocity positive, coming back to observer velocity negative. So it means this velocity I will take as a negative before collision and this after collision negative because both are coming towards. A is a 2.5, 2.53 and 3. Before collision, this speed is what? Let me check on top. There's a 3.5. And A, this is, I got it, just got it now, 4. Okay, 4. And what is a velocity after hitting? He's mentioned that 0.5 downwards. And this I don't, I kept X. Now, students, I'm going to apply the formula, and formula is very clear. You know it very well. What's formula we use? Normally, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Okay, before collision and after collision. So before collision, so this into this, time to this into this. Make sure this is for negative. So I'm writing here, mass is a 3 into 3.5. Mass is a 2.5 into negative 4. And what about this one, mass 1? So this, okay, this is a 3 times to negative. I'm writing here 3 times to negative 0.5. Okay, and 1 minute. And plus M2 is 2.5 into X. Again, I'm going to solve it and let me check in calculator. 3 times 2, 3.5 plus 2.5 into negative 4. Okay, and this turns to be 0.5. And 3 times 2.5, I'm getting here negative 1.5. And here I got a 2, and 2 divided by 2.5, I'm getting 0.8. So velocity of the A after collision is 0.8 meter per second. This is a very, very clear idea. But what the question is asking further? He is asking that after distance A will move up and after how much it will move up after collision. Common sense, when A is traveling after collision, what happens? Let's try to explain it. This is our A particle, so it will go and stop on the peak. So this starting velocity, this is a starting velocity now. Because after collision, so this velocity turned to be starting velocity, and last velocity confirm on peak is 0. And for your sake of your idea, acceleration is same value you got before. On the top is a 2, but negative 2. You may ask why negative 2, sir? Because it's going upwards, slowing down. So if in case of this is a experience, okay, whenever smooth, friction is 0, acceleration is positive and deceleration is negative, same number, okay. So I'm going to find it. So 2as equal to v square minus u square. 2a is a negative, 2s is a dot. To find use v0 and u is 0.8 square. So I'm finding now directly negative 0.8 square over negative 4. So when we type in calculator, okay, we are getting answer 0.16 meters. So just sake of your understanding, I can prove it one time, okay? Further, I will not improve. This is applied force, this is a frictional force, and this is mg sine theta or alpha. But in current situation, what is the formula? Net force is equals to ma. Because motion is upward, I'll start from here. Capital F minus small f minus mg sine theta is equals to ma. Because applied force, no, there it is going due to inertia. This is gone. No friction, this is 0. M is what? M is okay. Even I can cancel mg m from both angle even, very well. Like this, mass cancel. This 10, this is a point 2, and negative sign is there. You see, I got a same. So this is you understood now that acceleration and deceleration will be same always if particle remains same and forces remain same. Okay. So I think idea is very clear, and the question is completely clear. Question number 7, we have students. A particle starts from rest, okay, all right, and moving. And what does this mean? This mean whenever particle starts, so means time 0, start from a point O. So 100% distance 0. He did not say start from rest. He said rest, we can say V also 0. But in this condition, he did not mention particle start from rest. Start from O. When start from O come, when time 0, S must be 0. So let's student talk about the next part, point. Okay, my next point is what we have velocity given. We need to run acceleration. So students, we have a criteria whenever we have a displacement, we'll differentiate. We'll get if we differentiate with respect to time, we get a velocity. And we again differentiate with respect to time, we get acceleration. And if I want to come down, integration with respect to time. So this is a criteria. Okay. Right now I am on the velocity level. I'm looking for acceleration level. I have to go for differentiation, but before we have to multiply. So 2 into t is 2t to power 2, then negative 8t, then negative 3t, then positive 12. Okay, so I can say here this is a 2t square, negative 11t, and plus 12. Okay, I can further say 2 by 3. This is not important, which I'm doing. If you can keep outside 3, no problem at all. Anyway, this final form of velocity, now I'm differentiating. When differentiate, so 2 comes down power less, okay, 4 over 3t. And 11 over 3t becomes 1, and this becomes 0. He's saying find acceleration times 2. So I'm putting time 2 whole equation. So when I plug in 2 here, 2 fours are 8, 8 by 3 minus 11 by 3, and we are getting negative 1 meter per second square. So Alhamdulillah Rabbil Alameen, part 1 done. Let's go for part number B. Part number B, we have find total distance traveled from first 3 seconds. So it means right now we on a velocity level, I need displacement. So I have to come down for integration by integration. So what is a way? Look at now. This is, we have a formula. Okay, a expression given by him. If I integrate, I get S. But thing is that very important part is what we have. Whenever this condition comes, the total distance is asked and given. So we have to check it that is this particle, does the particle stop somewhere or not? And how to know that particle stops? So I will plug in velocity 0. You plug in this velocity 0, then you have to factorize a lot of work to be done again. So better to use the top function, and I put velocity 0. For example, I am putting here velocity 0. And when I put in velocity 0, so 0 is equal to 1 over 3, 2t minus 3 time 2t minus 4. So students, very clear, 3 into 0 will finish. So either this equal to 0 or this equal to 0. So we get a 2 times from here, 1 by 1. Here I got t is 3 by 2, 1.5. Here I got a 4. But because 3 seconds, so this is out of the range, I will not take it. And this I will take it to 3 by 2 or 1.5. So it means that particle is stopped in the middle, confirm, and 100% assurance, okay, even we can check it, and I'm going to show you the concept. If I plug in this, starting from 0 till 3 and zero point 0.5 gap. So let's see what happens. When I plug in 0 here and 0 here, I get a 4. It means the particle has a 4 here. If I plug in, let's say plug in, I think so, point to, because basically what I'm going to do, 0, 1, 2, and 3. 1.5 is this. 100% what my belief, the curve will come this way, and then curve will go this way. But for sake of understanding, do one thing, students. A gap, what is called step of 0.5 will use. Okay, and 1 minute please. I'm going to show you this whole thing in my calculator. So inshallah, I hope so you will understand. But before, let me write the equation, because okay, plus 4. Okay, now I'm going to show you the whole thing. You will come to know you have a positive 4, and then you have a negative positive, and is a negative. And you know, positive is going away, and negative, this blue x-axis, coming back. So whenever going away, there's a positive answer, and below, negative answer. Sake of understanding, we am going to use this calculator. I'm using the table function. Get ready. Table function is available with us here. And I'm going to type a function, same thing. Okay, 2 divided by 3 times 2, shift and x to power 2, minus 11 divided by 3 times 2x and plus 4. If I press it, he say, start from where? Start from 0. Ends where? And 3 seconds. Step how much? 0.5 gap. So look, you see the students, all values you can see, and look at now, you can see some values are positive and stuff. Look, after 0.5, at 0.5, we have a 0 number. You can see the 0 number. And after 0, they have a negative numbers. Can you see all negative numbers, students? At 3, we have -1. So I hope so you got a point very clear. And it means that is why we can say this is a positive, this above area, and is a below. And because below, so because this will give you positive area, positive, and this give you negative. So how we can compensate, how we can adjust this one? So we can do this distance. We will break in two parts. First 0 to 1.5, then negative sign, and 1.5 to 3. You may ask, so why putting negative sign here? Reason, because this negative value and that negative into negative give us positive. And here I'm writing the velocity, and I'm going to integrate. Velocity, integrate. So let's start. So idea is very clear, and now I'm going to integrate it. So S is equals to integral sine 2 by 3 t square negative 11 over 3 t plus 4 and dt, and 0 to 1.5. And same function, I'm just saving my time. Okay, wait a minute. This I'm writing 3, and this I'm writing 1.5. And now I'm shifting this. In the middle, I'm putting minus sign. You can see. Okay, now I'm integrating to get the answer. So what is integral here? 2 by 3. Increase the power by 1, divide by same. I'm writing 3 over 3. 11 by 3 already, power 1 to 2 by 2. And 4 become 40. Same story here, but here I'm writing 0 to 1.5. Here same story. I'm saving my time, 2 by 9 and t to power 3. 11 by 6 and t to power 2 plus 40. A limit is what is 1.5 to 3. Now students, I'm going to plug in the values, and when I plug in the values, what I get the answer. The first answer I'm getting is here after typing in calculator upper limit, because upper limit 0 plug in, I'll get 0. So here I'm getting 2.625 and negative sign. And this will give us what? Upper limit and minus lower limit. I'm getting negative 1.25. And that is by total distance, what I get from here. If I add them, I get a 3.75. Let me check once again. 2.625 plus 1.25. Yeah, 3 point, wait a minute, 3. 625, and I think here I did mistake. Here this is 125. 1. Yeah. Now it's 3.75 meters. Alhamdulillah Rabbil Alameen. I think this point is very clear. And we have another part of this question, determine whether P returns to O or not. For that reason, we have to concentrate on distance. Your student, what is the technique? This displacement I need. Copy, and I'm doing a next page. So get ready for this part. So this is displacement, I got it. Basically, I got a C. But do you know, student, it was starting from the O. When time is 0, S is 0. If I put 0 here, 0 here, 0, 0, C becomes 0. So no need to write. No need to write this C. This is understood. This is a displacement. Whenever turns to O, for your sake of understanding, this is observer, let's say, a particle goes away, or let's say particles coming from back this way, this way, this way. So whenever he will cross observer, every 3-point displacement equals to 0. I believe you got a point. Every time displacement is equals to 0. Okay, forward displacement positive, backwards displacement negative, but beside of observer, displacement 0. So I'm going to put displacement is equals to 0. So when I put 0, 2 by 9, I can take t common from throughout. T common, I got a 2 by 9 t squared negative 11 by 6t and plus 4 is equals to 0. Either t equal to 0 or this full equal to 0. So I got two expressions. T we are not counting because it's starting, this starting point. So I'm counting the other one, 2 by 9 t squared negative 11 by 6t plus 4 is equal to 0. So we have two techniques. One, apply quadratic formula and show the answer and prove it this answer is not possible. Second option, this is value of A, this is value of B, and this is a value of C. You know discriminant will be squared minus 4AC. If this answer comes negative sign, because in square root we have B squared minus 4AC. Outside negative B and plus and minus by 2A. If this answer come negative, so we have no infinity, no real solution. It means it will not turn back. So let's see. Negative 11 by 6 square, 4 times 2a, 2 by 9, and c is 4, which I'm going to type in calculator. So 11 divided by 6 square, and negative 4 times 2, 2 over 9 times 2, 4. I'm getting negative 7 over 36, which is less than 0. So no real root will come from here. When no real root, so P will not return. Not return to O. So it will not turn back to the observer. I hope so. The concept of the question is completely. Question number 8, we have, students, a mass of a part block of mass A, by mass 2, okay, block A mass 2 kilogram and B mass 0.5 kilogram, okay, and mention here 15 degree and mention here 20 degree. An important part is that pull horizontal with acceleration. So acceleration is given by him. Let me write on top. Acceleration is 1.2 meter per second. Okay. So, and applied force is here acting 6 newtons. Okay. Further, he's saying mm, the contact between is smooth. So this is a smooth and A is a rough. So here no friction, here friction is equal to 0, but here friction is not equal to 0. Okay, and what he's asking for is rough. Okay, find the tension of string. So how to find tension string? You know it very well. We have this criteria. If a pulley is this and string is passes over this one sort of way, tension towards always pulley is a rule. And when we have a pulley, is this condition so the tension again towards pulley is very, very clear. Even the question comes the vertical pulley, for example, this tension again towards pulley. And what if this pulleys are not there and string becomes straight? So tension towards each other. That is why I can make it this idea clear, because some students confuse the why I'm writing these two tensions. So this tension and this tension. So this tension is equals to each other. But right now he's asking the fine tension string. So I take one tension only, and that is this tension. Okay, this tension. It has two components. One component acting here is with 15 degree. It is called T cos 15. And one this acting T sine 15. So this part is very, very clear. Why I'm not considering this? Because it has some frictions that will create a problem. But here, no friction, so I can work with this easily. And basically, friction is backward, but friction backward is zero. So I'm going to apply net force M is here rule. So net force is equals to MA. I can work for this even, but 2 marks only. It will take a lot of time due to the friction not equal to zero. So I have to work with this. So because system is going left side, the motion is left side. So this component is bigger. And I'm writing here T cos 15 minus friction, which is zero. Mass is B particle is zero point 0.5. Acceleration, we have 1.2. If it is come down, I will find tension in quick time, zero point 0.5 into 1.2 and divided by cos 15 degree. And what I get answer, I'm getting here 0.62111. I think 621 Newton is enough, and we got this answer. So first part is done. Further, what he's asking, let me check the below. Any part is below. Okay, maybe on the next page we have, yeah, the find the coefficient friction between A and surface for 6 marks. So coefficient friction means mu we are looking for. So let's try to do a same page. For that reason, it is understood that tension value is this. Okay, tension value is clear. Now, situation is what I'm erasing it now, whole thing, and I'm going to plan this. But as I said before in the beginning of the topic, this question, sorry, I said that tension always towards each other and both values are same. But now I'm considering the A object. So I will not consider this force. No, I will consider like this is going this way and this particle is behaving like a frictional force. And basically it is a pulling backwards. So I will take this tension. I will take this tension, and it is obviously it is a very clear. So if I make it one component tension is this way, and one tension component is this way, and 15 degree here, and this become T cos 15, and this become T sine 15. Okay, this is a very clear. Basically, tension is acting this way. So this I talk about, which is acting on this object. Don't think so. It is acting on B. B is acting tension this way, which I'm not considering now. I'm considering only that tension which acting on the A. One time I use B particle only. I did not consider A. And now I'm considering A only. I'm not considering B. So make sure. So now what is a mass of this is 2 into 10. This becomes 20 Newton downwards. And upwards R component. Okay, and this force has also two component. This 20, so this 6 cos 20, and this will be naturally 6 sine 20. I think idea is very clear. And we are missing one component because motion is this way. And motion of acceleration is given by him is 1.2. Yeah, 1.2. And we missed one part. And what is that? Frictional force acting backwards, which I'm showing it backwards, friction force. So now if you look at carefully, we have a horizontal component parallel to surface and a vertical component perpendicular surface. So let's start first perpendicular. These two forces acting upwards and these two forces acting downwards. According to criteria, upward force equal to downward force, I can say here R R plus 6 cos 20 is equal to 20 plus T sine 15. Okay, so this is done, and now I bring this component on the other side. So I can say R is equals to 20 plus and t value 6.21. So 0.621 sine 15 sine 15 and negative 6 cos 20. In this way, I can find out the R value in quick time, which I'm finding now 20 plus 0.621 into sine 15 degree minus 6 times 2 cos 20 degree. I'm getting 14.5 to 57. Okay, newtons. I got this one normal reaction force. Okay, now I'm talking about horizontal components because system is moving left side, so I'll start my solution from here. So this positive, this negative, and this negative equal to MA. So I'm starting here. Net force is equals to MA. All right, I'm writing first of all 6 cos 20 minus friction minus T cos 15 is equals to MA. M is 2 and acceleration is 1.2. Let me recheck. Friction force and tension component, and that's it. Okay, let's try do it now, finalize it. So I will bring simple F on the other side, rest all and the left side. So I'm getting 6 cos 20 minus tension value is 0.621 cos 15 and minus 2.4. This comes from left side, right side, sorry, equal to T is equal to, I missed, I think, so this is done, okay, is equals to friction force, which is equals to mu R. And I'm writing here mu R. And R value is this. Okay, now I'm typing it, and mu is equal to basically 6 cos 20 minus 0.621 cos 15 minus 2.4 and divide by R value, which is this. So 14.52257. Okay, students, I'm typing it, and 6 times 2, I'm writing 6 times 2 cos 20 minus 0.621 times 2 cos 15 and negative 2.4 and divided by our R value. And we are getting the mu value 0.18167. After rounding, I don't want. So 0.182 coefficient of friction, we got it. And I hope so. The component breaking is the most important, is a part of a solution you must show on diagram. Otherwise, you will lose some marks. I hope so. The concept is very. And paper is completely done. And best of luck for upcoming exam. And best way of if you have done some mistake. So please watch it carefully and practice again after watching. Okay, it is very compulsory. And if you will not practice again, no improvement will come. So best of luck for exam. Assalamu alaikum wa rahmatullahi wa barakatuh.